Masroor, Hema, and Avinash. Engineer Avinash Kumar Singh, I think. Uh, Hello, Avinash Singh.
Yes, sir.
Yeah. You were absent for many days, I think.
No, sir. Last class I was absent.
So you were present last time.
I think I have not taken Monday class, sir.
Yeah, yeah. So that was a very. But you please go through that recorded session because that was very important, and I have talked a lot about how we are going to use uh, uh, for seismic analysis, lateral load analysis, and today that is a continuation of the same class. So if you have any doubts, you may ask me by phone or etc. But I will advise you to go through that session because
Okay, sir.
yeah, that was a very important session. Uh, anyway, so there are how many people are there? So can I start? Because a
Yes,
lot of
sir.
people are yet. But I just can't wait.
Yes, sir.
Yeah. Okay then. So this okay. The is this slide that everyone can see this slide? Yes.
Yes, sir.
Okay. So we were talking about this. So what I'm just going through the quick review that we were interested in finding out seismic analysis with the help of equivalent static method, and we had understood the input. So this is the input that we are having 20-meter in x direction and 15-meter in y direction with all these cross sections. We are having columns, and this is a panel, and you can see this was the elevation. Then this was the input data for our structural reference. So the loading that we are considering 12 kilonewton per square meter on floors, 10 kilonewton per square meter on roof. Similarly, live load is 4 on floors and 1.5 on roof. And our objective was to find out story shear and base shear by equivalent static method. So first we'll be calculating base shear, and then this base shear will be distributed at every floor so that we'll find out a story shear. Okay. Then you have gone through. So this was the basic equation that we are going to use for calculation of seismic base shear, and that is VB equal to AH into W, where AH is a seismic acceleration spectrum value or design acceleration coefficient, and W is the seismic weight. So you can see that so AH can be calculated by this formula, and you can write this formula as Z by 2 SA by Z divided by R by I. So as per our new code convention, but it is usually the same. Then we have understood what is Z, what is I, and then what is R, and how this R is important, and what is its conceptual understanding. So all that we have seen, and now we are going to look into this SA by Z average response acceleration coefficient. So we were up to this, no? Okay, then let us see that the this was also we had understood the these are the design parameters for our present problem. Then uh, this is the seismic map of the India. It has been divided in four different zones, namely zone number 2, zone number 3, zone number 4, and 5. Or you can get the same information as a major cities in India. So you can see that if you want to see the Agra, Agra is situated in zone number 3. Or if you want to see the Bhuj, Bhuj is situated in zone number 5. Okay. Then This was where you will get importance factor for building. And then you can see this response reduction factor. So if you are having special RC moment resisting frames, you can consider R equal to 5. Okay. And then we'll go into this a bit later. And this also will go in. Now you can see how. Okay. Now we'll start our session. Yes. Is there any problem till now? I think we have discussed all these things in detail.
Yes,
Hello.
sir.
Yeah. Now, now the basic we were looking into that. We were interested in finding out VB, and that was equal to AH into W. So now we have seen how AH can be calculated with the help of that Z by 2, I by R, SA by Z. In that, SA by Z is not yet understood by us. So, other thing. Now, the next parameter is seismic weight, and how the seismic weight will be calculated. You can see over here. Okay. Now, it is very simple. Just try to understand it because it is as per our assumption. What we are assuming that actually the weight of the building is not concentrated at any point. It is distributed all over the plan area as well as all over the height. So it is uniformly distributed in plane as well as in the elevation. Clear? Hello.
Yes, sir.
But that for our calculation, we are considering that entire weight of a floor will be assumed to be concentrated at the CM or center of mass of the floor. Then what will be about the weight of wall and weight of columns? You can say that for floor, you can assume this point. Okay, for this floor, this this point for this floor, this point for this floor, and so this is about uh, floor weight. Okay, which will be considered as weight of the slab, then weight of the beam, and any additional live load and superimpose dead load on the floors. Clear? But what about the vertical weight, which is in between the two floors? So for that, the code says that up to mid height of the floor above and below will be calculated and assumed to be concentrated over here. So that's why you can see this red mark. So 50% above, 50% below will be calculated and assumed to be acting at the center of mass for that floor. So you can see for first floor, you will see that this is the mass for floor, 50% above and 50% below will be considered. So this much, this much mass, whatever it may be. So from plane to that will be missing. Clear? So you can call this as a missing mass. That is okay. Then for second floor, you will see that 50% below, 50% above. And for terrace, you will see that weight of the floor at terrace plus 50% below, 50% below over here will be considered over here. Clear? So it is very simple. Yes, any doubt into this? Hello?
No, sir.
Okay.
No, sir.
Now let us see what is the assumption for dead load and live load. You can see that if this is your terrace or roof, whatever you call, so that is a W4. There you will consider only dead load. Of course, it includes superimposed dead load also, but it will not include any live load. So whatever live load on the terrace that you are considering will not be included in calculation of seismic weight of the terrace. Clear? So no live load is considered at terrace. Then for floors, you will see that full dead load plus some percent of live load. So how much that some percent, that we'll see after. If live load is per square meter, so then that 3 kilonewton would be multiplied by the entire area. So whatever will be the total weight, some percent of that will be considered, not 100%. That's why here we are saying that no live load at terrace and some percent of live load. So I will consider dead load every time and some percent of live load. Can you understand, explain the idea behind this some percent? Let us say, for example, I'm considering 50%. Or maybe 30% or maybe 20%. That means if I'm considering 40%, that means I'm neglecting 60% of live load for calculation of seismic weight. Why so? Is there any reasoning for that? Hello? कुछ अंदाजा? Try to imagine.
सर क्योंकि ऊपर के फ्लोर्स का भी ऐड ऑन हो जाएगा नीचे को
ऊपर क्या? हेलो?
जो अबव फ्लोर्स हैं उनका लाइव लोड भी नीचे ट्रांसफर हो जाएगा
No. We are
ऐड
not.
ऑन हो जाएगा
Okay, 1 minute. We are not calculating any reactions. See, when you are calculating reactions, only then you can say that the load above will get transferred below through the columns. Then it will be transferred to the below floor. It is not transferred on floor. It is transferred on the columns only. Make it clear. See, if you are having a 70-story structure, that doesn't mean that the floor at first floor or maybe at plinth is supporting all the load above. No, floor will be subjected to the load on that floor only. Then the above floor load is transferred at that floor level on beams, and from beams it will be transferred on columns, and from columns it will be transferred on lower columns, right? So that is different thing. Okay, let me tell you, see what will happen. First think about the earthquake phenomena. When earthquake is going to hit this structure, at what time? At 10 o'clock in the morning, or 12 o'clock at noon, or maybe in night. When earthquake is going to or when this building will be subjected to earthquake loads. कब आता है earthquake?
Unexpected is.
उसकी मर्जी, उसको जब आना है तब आता है, right? Your building may be subjected to earthquake early in the morning or maybe late in the night or any time. So that we do not know. Okay. Now let us see that it is this building is subjected to earthquake due to earthquake activity. It is subjected to earthquake loads late at midnight. What is the chance that 100% live load will be available over there? हो सकता है ना, अगर बिल्डिंग कमर्शियल है तो शायद सभी लोग अपने अपने घर गए, तो ये बिल्डिंग में दिस बिल्डिंग विल बी सब्जेक्टेड टू ओनली डेड लोड्स, may not be a superimposed load, that is live load. So the presence of live load at the time of earthquake is may not be 100%. That one can assume 100%. See, if you are considering 2 kilonewton per square meter as your live load intensity, okay. So this 2 kilonewton on every floor the chances of this having a maximum of 2 kilonewton per square meter is rare. That means on this floor, there may be a night party, so this floor may be subjected to 2 kilonewton, but this floor may be subjected to 0. This floor may be subjected to 10%, etc. All floors having their full intensity of live load at the time when the building is subjected to earthquake loads, this possibility is rare. Clear?
Yes, sir.
And that's
Yes, sir.
why, that's why we are interested in finding out the actual base shear that the building is subjected to regis. So that depends on live load intensity, dead load intensity, etc., etc. And one thing is that once the building is constructed, entire dead load will be always there. Earthquake दिन के किसी भी समय आए, रात के किसी भी समय आए, ऐसा नहीं होगा ना कि डेड लोड कम आए. डेड लोड तो जो है उतना पूरा का पूरा रहेगा. सो वी आर नॉट रिड्यूसिंग in dead load quantity, we are reducing only live load, and that too we are not considering. So with some probabilistic approach theory that has been devised by the codal provision, we can go for, and now that is given in 1893 like this. See, table number 8 of 1893, clause number 7.3.1 says that percentage of imposed load to be considered. It is not saying, it is saying that to be considered in seismic weight calculation, not in design. Only whenever you are going to calculate seismic weight, for calculation of seismic weight only, this clause is applicable. And what is that clause? You can read it over here. So impose a uniformly distributed load intensity up to and including 3 kilonewton per square meter. अगर ये इंटेंसिटी आपने कंसिडर की है आपके नॉर्मल कैलकुलेशंस के लिए, ग्रेविटी कैलकुलेशंस के लिए, तो you can consider percentage of imposed load only up to 25%. So 75% load is not considered in terms of live load only. Yeah? Don't do it for total load. Clear? And
Yes, sir.
अगर आपका live load intensity is more than 3 kilonewton per square meter, in that case you have to consider 50%. Clear?
Yes, sir.
इसका कंसेप्ट आपको समझ में आया? Why the code is allowing you to reduce the magnitude of live load, not dead load. Okay?
Yes, sir.
But earthquake phenomena is rare and nobody knows when it will occur, and even if it occurs at daytime also, what is the probability that every floor will be subjected to its highest load considered? Clear? So that's why reduction is allowed by code, and we are following codal provision, and that's why we say that our 1893 says that you can consider if your live load intensity is less than or equal to 3, you can consider 25%. That is okay. And if it is more than 3, then it is 50%. Clear?
Yes, sir.
Yeah. Now the calculation. This is your seismic weight calculation. Now everything is very simple. You have to go to your data, and your data is saying that this is your area, plan area of the building, and this is your height of the building, number of floors, and this is your data that you are considering. So at floor, you are considering 12 kilonewton per square meter, and at live load on floors, you are considering 4. On terrace, you are considering 10 as a dead load and live load equal to 1.5. Right?
Yes, sir.
Now this 12 consists of 50% below and 50% above. This live load also consists of 50% live load below and 50% live load above. So that's why these figures are considered. But in actual practice, you will have to calculate 50% above in terms of superimposed dead load, 50% below. Then you have to add it in dead load. But for some simplification, we are finding out equivalent dead load and live load intensities that we are assuming on the floor. Clear? So you just have to look into this and plan dimensions. These are your plan dimensions, and based on that, you will see that the live load calculation is like this. So the floor area is 15 multiplied by 20. That comes out to be 300 square meter. Since the live load class is 4 kilonewton, which is greater than 3 kilonewton per square meter, that's why 50% of live load is lumped at the floors, and at roof, no live load is to be lumped because code says do not include any live load on terrace for calculation of seismic weight. Again, I am saying for calculation of seismic weight. Then you can see here W1, W2, and W3. These are the 3 floors in consideration for the example. So 300 is the area, 12 is the dead load intensity, and 4 is the live load intensity multiplied by 0.5. So total intensity will be 12 plus 2, 14 multiplied by 300 will come out to be 4,200. So finally, I will say that seismic weight at floor 1, 2, and 3 is coming out to be 4,200 kilonewton. Clear?
Yes, sir.
Now at roof, it is simply a dead load. So 300 multiplied by 10, because 10 is the intensity of the dead load that we are considering. And so 3,000 will be on roof.
Okay, sir.
So what will be total? By 3 plus 3,000. So that is calculated over here. And finally, you will see that total seismic weight of building that you are going to consider for calculation of this shear is 15,600 kilonewton. Clear over?
Yes, sir.
Yes, sir.
Any doubt? Now we are here, and the first thing that this was, let's say this was your building. So I'm showing you again mathematical model. नहीं तो बोलेंगे सर ऐसा कोई बिल्डिंग होता है क्या? Right? So this is M1, M2, M3, M4. These are the masses, and these masses, due to the earthquake activity that is it is subjected, it will deform like this. So this is our fundamental mode or first mode. So the fundamental mode will give you deformation over here like this. And this is calculated with respect to T. So you can see fundamental time period calculation. Now actually this is a dynamic behavior. So you have to go for dynamic analysis, but for certain conditions, you have to find out with empirical law. Now this is the empirical law that code has given to you. You can see lateral load resistance is provided by moment resisting frame infilled with brick masonry panels. Hence, approximate fundamental natural period as per clause number 7.6.2 of IS 1893 part 1. This is the formula that has been given by code, and this is empirical formula. And what is the meaning of empirical formula? Hello.
Experimented on several times and then it will derived.
Derived. So it does not. If you ask me the proof of this formula, there is no way that one can define it mathematically. That's why we call it as empirical formula, because it is based on n number of previous data, observations and calculations and everything. And finally they say that shayad ye ho sakta hai. There are n number of empirical formulas applied all over world. Every code is having empirical formulas based on their studies. Now IS 1893 says that if it is infilled with brick masonry panels, then you have to use this formula as empirical formula. And if it is a bare frame, does not have any infilled brick masonry, so only a bare frame, that you can say that if you are going for a water tank, elevated water storage tank, it has a frame only, and then on top there is a water tank. In that case, you don't find any BB masonry over the beams. In that case, code says that the formula is something like this: TA equal to 0.075 H raised to 0.7. Say that approximate formula can be equal to n by 10, where n is the number of stories. So in our case, what will be the TA if you are using this formula? 4 stories divided by 10, so 0.4. So time period, fundamental time period is 4. Or you can use this, or you can use this. But this is recommended when you are having infield BB masonry. Okay, so don't worry about these formulas. But these are also the empirical formula that code is using. That's why, just for your information, I have shown you this. And every formula, you will say that it is based on observations. Clear?
Yes,
now,
sir.
Now you can say that 0.09 is a constant, so you don't need any information for that. H is the height of the building in meter, defined in 761. That is at plinth level or at ground level. So whatever may be the, if this is your ground level, and these are your floors, then H will be measured from ground floor to terrace. So that will be H. Clear?
Yes, sir.
Don't measure it from footing. So let's say you are having a footing over here. So don't measure it from footing to that. Why I am saying? Because in ETAP model, we say this is our 0, and then we are going for height of the floors, right? So this H is measured from ground level and not from footing level. Clear?
Yes, sir.
So H का तो काम हो गया. So you know H. If you know the dimensions of the structure, height of the structure above ground, that is the H. Now this D. D is a base dimension of the building at plinth in meters along considered direction of lateral force. Again, if this is your plan, let's say this is your plan, this is your X direction, and this is your Y direction. So whatever is the length, that is for calculation purpose for earthquake in X direction. Okay, so whatever may be, in our case it is 20. And if we are applying earthquake in y direction, so this will be h, this will be d, and in our case it will be 15. So these dimensions, see, d means not depth, d means dimension in the considered direction of the earthquake or lateral force. Clear? Hello.
Yes, sir.
So you can find out the time period, that is a time taken by the building to complete one cycle of vibration. That is period of vibration, and it is denoted by TA in our case. Clear? Now once you know this, then you can find out earthquake in time period in x direction. See here 0.09 h or root d. So root d means root of 20 in x direction. So it is coming out to be 0.28 seconds. Clear? Hello.
Yes, sir.
Now why we are calculating this? Because based on this, we'll be calculating SA by Z. And for that, you will have this type of response spectra. Now this is a response spectra for 5% damping with different soil conditions. Now the soil conditions in India, we are considering type 1, type 2 and type 3. So type 1 is for hard rock or hard soil. Then type 2 is for medium soil and type 3 is for soft soil. Okay, only the three types are considered. So either whatever may be your foundation strata, that you have to consider it in one of the three conditions. It may be soft, it may be medium, or it may be hard soil. Clear?
Yes, sir.
Now, in our case, we are considering medium soil. So we'll be using this for this curve. Now, what is this curve? And what is the meaning of this curve? This is a response spectra for 5% damping with different soil conditions. Now forget about that different soil condition. Now we are concentrating on type 2 because in our data, what data we are getting. So this was our, so soil condition medium steep. Clear? So we are going for type 2. Yes. Hello.
Yes, sir.
Now, what is this response vector? Anybody has any information? Hello. See, this is very important because I have seen many people using everything blindly and then they don't have the confidence on what they have done. I don't want that to happen with you. That's why I'm trying to explain each and every word. Just anybody. अरे आप में से पोस्ट ग्रेजुएशन किसने किया होगा ना? हेलो. और आजकल आज के आई थिंक इन दिस era that earthquake dynamics or structural dynamics is also taught at graduation level. In our era, it was only a syllabus in post graduation level. But right now, I think in final year, you calculate this equivalent static load method, you apply it and you find out base shear, etc., etc. So at least this equivalent static method is included in your graduation level. So at least कुछ तो पता होगा. गलत सही वो बाद में देखेंगे. Or this is the first time that you're coming across this response spectra word. Hello.
सर नहीं पता है.
ओके, एब्सोल्युटली कुछ पता नहीं।
नहीं सर।
अच्छा, ऐसे कितने लोग हैं जिनको एब्सोल्युटली कुछ भी पता नहीं है, यह है क्या?
नहीं पता सर।
ओके, अच्छा, कौन है आप में शायद उसको थोड़ा बहुत गलत सही वो बाद में देखेंगे, मगर थोड़ा बहुत उसने सुना है।
सर मुझे एक गेस करना है
हाँ,
कि सॉइल मतलब कितना वो ऑब्जॉर्व कर सकती है वाइब्रेशन को, उसके हिसाब से मे बी।
एक्चुअल में सर ये शायद जो मैंने पढ़ा था उसमें ऐसा था कि टाइम पीरियड से रिलेटेड है कि अगर जैसे जितना हार्ड होगा उतना कम टाइम उसका वो रहेगा, इस टाइप से कुछ रिलेशन है उससे रिलेटेड
ओके ओके।
डैम्पिंग का।
नहीं, डैम्पिंग इज अ पैरामीटर बिकॉज ऑफ विच द वाइब्रेटिंग स्ट्रक्चर कम्स टू एट्स रेस्ट। अगर वो डैम्पिंग नहीं होता था ना, तो वो हमेशा के लिए वाइब्रेट होता था।
यस।
तो डैम्पिंग की वजह से इन एवरी साइकिल ऑफ वाइब्रेशन द एम्पलीट्यूड ऑफ दैट स्ट्रक्चर और दैट मे बी सिंगल डिग्री फ्रीडम और मल्टी डिग्री फ्रीडम, that amplitude of the structure starts reducing. That is the effect of damping. But what is response spectra? Okay, I will assume that no one of you does not know anything about response spectra except the word, और वो भी बहुत सारे लोगों ने आज पहली बार सुना है। ऐसा assume करूं मैं?
बिल्कुल सर।
ये आपके लिए फायदेमंद है या नुकसानदेह है? कोई बात।
फायदेमंद होगा, आप बता दीजिए सर अभी।
Okay, okay. Okay, so what I will do, I will go ahead and somewhere I want the. Okay, here I am having some space, so I will try to explain that. See, the word response spectra. Response means it is a response to something, right? Somebody is asking you something and you are responding to his request or order or whatever. So some action is there and there is a response to that action. And what action we are actually in this case we are finding out? Earthquake activity. Okay, so this is the earthquake activity and this is your structure. A structure is responding to this activity by vibration. Clear? And that's why the word is coming response. It is a response of the structure to the external action of vibration due to earthquake. Itna clear हुआ? Hello?
यस सर।
Now the spectra. Spectra means what? It is a graph of different reactions. मान लो आपका ये earthquake, आपका अर्थ का सरफेस ऐसा है और यहाँ पे एक छोटा बिल्डिंग है। ओके, फिर यहाँ पे इससे थोड़ा बड़ा बिल्डिंग है, फिर यहाँ पे ये बड़ा बिल्डिंग है, फिर ये बड़ा बिल्डिंग है, ये बड़ा बिल्डिंग है। ऐसा हो सकता है क्या आपके इलाके में सारे बिल्डिंग का हाइट एक ही है?
नो सर।
Every building, depending on its use, then the person who is building, depending on his requirement or the money he is having, every building will have a different dimension. So the plan dimensions will be different and elevational height will be different. Now I am saying that there are so many n number of buildings that are situated at the surface of Earth. Okay, and there is a earthquake eruption. क्या सारे
Yes, sir.
every see this is a single earthquake? Okay, due to earthquake, this earthquake has vibrated the base. सारे बिल्डिंग का बेस एक ही है at the surface, and earthquake is coming with some U double dot. U means deformation, double dot means derivative. So U double dot GT. So earthquake is a motion, and that motion is having some acceleration. U double dot G of T. G means ground and T means at any time T. So as the T changes, the acceleration will also change. Yes or no? So
yes sir.
earthquake एक ही है. Now इस एक earthquake को सारी बिल्डिंग सेम रिस्पॉन्स देगी या हर बिल्डिंग अलग अलग रिस्पॉन्स देगी?
अलग अलग देगी सर.
अलग अलग देगी सर.
क्योंकि every building is having a different character, right?
Yes, sir.
So at any time t, this building may vibrate in this side, this building may vibrate in this side, this building again may not vibrate, this building may vibrate in this side but a slow, then this will this, and this may vibrate highly. Yes, ऐसा हो सकता है ना, because every building will have, now at any time one building may vibrate to the left, another building may vibrate to the right, and with different deformation. क्या सारे बिल्डिंग का एक ही डिफॉर्मेशन होगा?
नहीं सर, डिफरेंट होगा.
Okay, now why this is happening? Because though the earthquake is same, this earthquake is carrying bunch of frequencies, and these all buildings are also
different
having
height.
bunch of natural frequencies, right?
सर इनकी हाइट भी अलग है, तो इस वजह से भी होगा ना.
That I'm considering as a dynamic behavior or dynamic character.
Okay.
Right. So the dynamic character of every building is different, and when you are having different character, you will also respond in differently. Yes.
Yes sir.
Okay. Now the earthquake is same, but the building is performing a different behavior. That's why I cannot apply this earthquake in the same way that I am applying to this or I am applying to this. Solution क्या है? क्योंकि you're going to work about future building which is having a different character. Let us say this is your existing building, and if you not be for this. So all this different analysis or different parameters, they are combined in one form, and that is a spectra of behavior. So this will have some different behavior, this will have some different behavior. Agree? So every building, let's say there are n number of buildings, so n number of buildings will behave in n number of different ways. So that is a spectra. So the response of the building, that you can get in single graph for any earthquake, is considered as response spectra. थोड़ा समझ में आने लगा?
Yes sir.
Now how it is calculated? Let's see. This is your one axis, this is your another axis, and this is your third axis. Now on this axis, I am calculating or I am finding out u of t. So this is deformation. If I say u dot of t, this will be velocity. And if I say u double dot of t, then this will be acceleration. Okay. On one axis, I am calibrating u double dot of t. On another axis, I am calculating time period in seconds. This is not time, this is a time period. Right? Clear?
Yes, sir.
And on third axis, I am applying actual seismograph that I am getting. Now this I can get through seismological survey. So every earthquake will give you something like this. Yes? Clear, Aura?
Yes, sir.
Yes, sir.
Now here you will say that t equal to 0. This time period is equal to 0. Let's say here it is t equal to 1. Here it is t equal to 2. Here it is t equal to 3. And here it is t equal to 4. Okay. I'm showing you the concept. Now for t equal to 0, there will be acceleration like this. Now this maximum deformation or acceleration is plotted over here. Okay. So out of all these data, because every earthquake will have I think infinite data. So out of that, you will see I have collected only maximum deformation or maximum acceleration. Now for t equal to 1, I will have another something like this. Then maximum is plotted over here. Similarly, this will have something like this. So out of that, maximum is plotted over here. Maximum is plotted over here. Right? Similarly, maximum is plotted over here. So let's say this is maximum. So every one point on this plane is a representative of maximum response of the seismograph. Right? And then I will draw the graph. Something like this. Connecting all points. So this is called response spectra. And this is for, say, some damping percent. So similarly, I may have a response spectra for damping equal to 1%, damping equal to 2%, damping equal to 4%, 10%, 20%, 50%, 60%, all that. Right?
Yes, sir.
So this is whatever curve that you are getting from maximum. Now, why only maximum is considered? That is our basic. See, we are always interested. We are not interested in finding out the history of deformation. So at t equal to 0.1 second, what was the deformation? T equal to 3 second, what was the deformation? T equal to 3.1 second, what was the deformation? I'm only interested what is the maximum deformation, so that I will try to design the building to sustain that deformation. Rest of the deformations will be automatically taken care. Clear? Yes.
Yes, sir.
So as a structure engineer or as a civil engineer, I am not at all interested in knowing history of the axillogram. So this is the history of axillogram, but I am not interested. I am only interested in maximum, right? That I am plotting over here, and what I am getting is a response spectra. Clear?
Yes, sir.
Now this work has been done, and that will give you a spectra or a response spectra, and that as per our codal Indian code has also gone through all these observations, and finally they say that this is your response spectra for one type of soil, for another type of soil, another third type of soil. Up clear over?
Yes, sir.
So this is the time in periods, and this is a spectra, and this is SA by Z, where SA is spectral acceleration and G is ground rate. So this is a ratio. So spectral acceleration coefficient SA by G. अब पता चला why you are finding T, because you are not interested in T, you are interested in finding out SA by Z.
Yes. Yes, sir.
Clear?
Yes, sir.
So in above, you have calculated T, which is 0.28. Yes.
Yes, sir.
And for this building, for T equal to 0.28, you are getting the response spectra that has been derived, designed, and given to you as a ready-made parameter, and you can find out 0.28, 28, so 2.5. Clear? Clear हुआ?
Yes, sir.
अब रिस्पॉन्स स्पेक्ट्रा बहुत गड़बड़ी वाली चीज है, ऐसा मत समझना, ये बहुत सिंपल है, बट पीपल डू नॉट गो इनटू इट एंड दे से दैट नहीं यार कुछ पता ही नहीं चलता क्या हो रहा है, बस ऐसे वो ग्राफ रहता है, उस पे वो कुछ है वो लेके बेसियर निकालेंगे और छोड़ देंगे, मरने दो, ऐसा होता है ना. ओके, नाउ अगर आप में से किसी को रिस्पॉन्स स्पेक्ट्रा calculation or how it has been developed, why it is smooth, because I always ask people that any acceleration, if you find any accelerogram, it is something like this, और यहाँ पे देखे तो ये स्मूथ है, ऐसा तो कहीं भी नहीं है ना. At any time you find out the accelerogram and you will find this complicated figure. It is changing at every fraction of seconds. It is changing, and here you are getting very smooth, and that's why it is called. It is not a actual response spectra. It is a design response spectra. So whatever you have applied for one accelerogram for various time periods, entire earthquake data is calculated, then it is summarized or made uniform so that you will have a conservative SA by G, right? Because this response spectra concept helps you to analyze your structure for future earthquake. अब जो हुआ ही नहीं उसके लिए उसके बेस पर आप कैसे निकाल रहे? ठीक है, कोई कह सकता है कि if I have got the Bhuj earthquake data, I can design a building for that Bhuj earthquake data. मगर भुज earthquake एक बार हुआ, दूसरी बार नहीं होने वाला, उसी जगह हुआ तो भी वो अलग होगा, right? Every earthquake is different. Even if it is occurring at same place, it will give you different characters, because every earthquake on itself, it is very complicated, it is different and never repeated. ऐसा आज तक नहीं हुआ कि earthquake जैसा था वैसे ही वापस रिपीट हुआ. ओके, So then how you can judge? That's why this this is not only response spectra, this is a design response spectra. So all पिछले जितना भी डेटा आपके पास है वो सारा डेटा यहाँ पर मैनिपुलेट करके उसको एवरेज करके you are getting a design response spectra that can be applied to previous earthquake as well as future earthquake. जो नहीं आया उसको भी predict करने का ये तरीका है. That's why I will say this is not response spectra but a design response spectra, because actual response spectra and design response spectra is different. Clear?
Yes.
Okay, so this is actually थोड़ा मैंने जितना समझा सकता हूँ उतना समझाने की कोशिश की है. अगर इसमें से कुछ अगर आपको नहीं समझा, you can go and see this session again. But even if you do not understand, you can consider this as a design response spectra that has been supplied by code, and you can design all your code. So only the thing is that you have to find out T, and based on T, you can find out your graphically. Let's say we are having T equal to 0.28. So this is 0.5. So it will be somewhere here. And if I go like this, so if I draw a vertical line and then I go to this, I will go to 2.5, right? So SA by G that has been calculated is 2.5. Clear?
Yes, sir.
Now, अब में से कुछ लोग बोलेंगे सर वो तो ग्राफिकली हमारा स्केल वगैरह एक्यूरेसी तो अप्रोक्सीमेट. या डेफिनेटली इट इज अप्रोक्सीमेट, it's not exact. But even if you want the equations of these curves, you can see that this is a straight line, this is a straight line parallel to x-axis, and this is a logarithmic decay curve, and there are three curves. So all these three curves are having common horizontal line and common inclined line for something over here. When you are going to, let's say, if you are calculating your TA equal to 1.5, then you can see that for type 3 soil, you will get this. For type 2 soil, you will get this. And type 1 soil, you will get this. Clear? Yes?
Yes, sir.
Now, अगर आप बोलेंगे सर ये approximate होगा, we want something very very close, then you can go for equations also. The equations of all these lines is given, and you can check it over here. See, for hard soil, 1, 2, 3. So first is linear up. So that's why it is a linear equation, 1 plus 15t. And that is a range is 0.00 to 0.1. That you can see over here. See, 0.00 to 0.1. You can get up to this. Okay. So from this, see, 0, 0, you are getting this line. See, 0, 0, you are getting this, and for 0.1, you are getting this, and this is a straight line and inclined. That's why you can see it's something like this. Okay, so this is the equation for first, and the time period that you can get it over here. So if you have a T in between 0 and 0.1, then you can calculate with this formula. For hard, for medium soil, again the formula remains same, and for hard soil, again formula remains same, right? Then for this time period from 0.10 to 0.4, you will see 2.5 and 2.5. For range of T equal to 0.1 to 0.4, and from 0.4 to 4 seconds, you will get this and this is your logarithmic decay, which will go like this: 1 upon t, logarithmic decay. Then from 0.55 to 4, you will get 1.36 upon, again it is a logarithmic decay. And for soft soil, 0.67 to 4, you get 1.67 by t, again logarithmic decay. Clear?
Yes, sir.
Yes, sir.
And exactly that is, so I will say either you can use this or you can use this, you will get the same answer. Clear?
Yes, sir.
अब आपको ये यूज करने में कभी कठिनाई नहीं होगी ऐसा मुझे लग रहा है. फिर भी किसी को डाउट है? यस, एनीबॉडी हैविंग एनी डाउट? अब सब कुछ तो आसान हो गया. अब क्या करना है? बस कैलकुलेशन करना है. फाइंड आउट AH, Z/2, I/R, SA/G. आपको SA/G मिला, आपको I पहले मिला, R भी मिला, Z भी मिला. Put it in the formula and get it. Now what this AH equal to 0.09 speaks to you. ये क्या बता रहा है? Let me draw it. VB equal to 0.09. No, I don't want that. VB equal to AH into W. अब यहां पे AH आपने ये निकाला. What it is saying to you? Yes? ये कुछ, see this equation is speaking with you something that you must not override. नहीं तो फिर पता नहीं फिर इसका मीनिंग क्या है. मैथमेटिकल इक्वेशंस रीड करना आपने पढ़ा है कि नहीं? क्या सिर्फ इक्वेशन मगअप की है और पेपर सॉल्व की है? क्या किया? यस. See, if I say y equal to mx plus c, ये इक्वेशन में मुझे क्या बताता है?
Slope of line having intercept on y-axis.
तो ये इक्वेशन आपके साथ बात कर रहा है, तो ये इक्वेशन क्यों नहीं बात कर रहा है? अब देखो वो कैसे बात करेगा. I will say VB divided by W is equal to AH. वही इक्वेशन है.
Yes, sir.
तो अब ये इक्वेशन आपको क्या बता रहा है? ओके, मल्टीप्लाइड बाय 100
रेशियो
करो. मल्टीप्लाई बाय 100 करो.
परसेंटेज.
तो ये क्या आया? 9%.
Yes, sir.
यस सर.
अब मैं ऐसे बोलता हूँ, VB इक्वल टू 9% ऑफ W. अब ये क्या बात कर रहा है? अभी भी बात नहीं कर रहे हो.
डिजाइन बेस शेयर 9% होगा बिल्डिंग के वेट का, स्ट्रक्चर के वेट.
राइट. अब ये जो हमारे एल्डर जनरेशन के लोग थे ना, वो इतने होशियार थे कि वो बोलते थे ये VB वगैरह निकालने की कुछ जरूरत नहीं, सिर्फ ये सिस्मिक वेट निकालो, अपने पास ये कुछ नहीं है. वी डोंट नो ZI SA/G, ये कुछ डेटा नहीं है. सेफ साइड 15% ऑफ W इक्वल टू VB करो, वो सेफ थे कि नहीं?
Yes, sir.
So earlier, in earlier days, when they were not having any data about earthquake, क्योंकि उनके पास कुछ इंस्ट्रूमेंट नहीं थे, कुछ नहीं, साइंस भी इतना आगे नहीं गया था, फिर भी उन्होंने जो बिल्डिंग्स बनाई है वो बिल्डिंग्स अर्थक्वेक को रेजिस्ट करती है, वो कोलैप्स नहीं होती, बिकॉज उनको एक जजमेंट था, अरे भाई 15% से नहीं हो सकता लैटरल लोड एट बेस। अगर अगर वो सिस्मिक वेट निकाला बिल्डिंग का तो उसके 15% के आगे नहीं जाएगा, और अगर थोड़ा डर लग रहा है तो 20% ले लो और डिजाइन द एंटायर बिल्डिंग फॉर 20% ऑफ वेट एज अ बेस शियर। तो कौन होशियार थे, हम लोग या वो लोग?
वो लोग सर।
तो आया ना, नेवर एवर से कि वो पुराने लोगों को कुछ पता नहीं था। दैट्स व्हाई whatever the buildings they have designed, still the buildings are standing stiff against the earthquake, और हम लोगों के बिल्डिंग उल्टे पुल्टे हो जाते हैं, बिकॉज वी आर नाउ इंटरेस्टेड इन इकोनॉमी। तो इसके लिए हम लोग ज्यादा एनालिसिस कर रहे हैं, बट दे यूज्ड टू से दैट पता नहीं है कितना ज्यादा आएगा, अब 15% लग रहा है, 20% पकड़ो और डिजाइन करो, थोड़ा सा हैवी रहेगा, साइजेस ज्यादा रहेंगे, बट बिल्डिंग विल बी सेम। Anyway, that is what I wanted. See, always try to understand. Every equation is saying something to you. So every equation has something to say you, or every equation is sharing something with you. आप थोड़ा ध्यान देंगे ना तो आपको पता चलेगा कि every mathematical equation is giving you some indications. Clear?
Yes, sir.
So
Yes, sir.
So this way, we have determined AH, and now design base shear is equal to VB into AH into W. We have found out W, which is 15,600, and AH is 0.09. So this is 1404. Find out the calculation, and you will see that it is coming out to be 1404 kilonewton. So that is the base shear. Now, where this base shear is acting? At the base. Yes. So
Yes,
this
sir.
is your VB. Now, this VB is to be distributed at every floor. कैसे डिस्ट्रीब्यूट करोगे? कुछ असम्पशन करेंगे। शायद आप में से कुछ लोग बोलेंगे सर एवरी फ्लोर को डिवाइड कितना है 1 2 3 4, सो डिवाइड बाय 4 करो और जितना आता है उतना यहाँ पे अप्लाई करो, इतना यहाँ पे अप्लाई करो, यहाँ पे अप्लाई करो, यहाँ पे अप्लाई करो। तो दैट इज वन असम्पशन। ओके, वेरी
Yes, sir.
वेग असम्पशन कि सबको थोड़ा थोड़ा दे दो बराबर है ना, but that
Yes.
is and this is how we should work. Okay, but that is a vague assumption. दूसरा व्यक्ति क्या कहेगा, सर ऐसा नहीं है कि ये थोड़ा इतना इतना सीधा सीधा नहीं कर सकते, तो whatever is this base, if I see the deformation, it is something like this. Okay, तो टॉप पे डिफॉर्मेशन ज्यादा हो रहा है, उससे थोड़ा कम हो रहा है, उससे थोड़ा कम हो रहा है, उससे थोड़ा कम हो रहा है, बेस कम हो रहा है, तो आई विल एज्यूम अ लॉ, लीनियर लॉ। ओके, तो इस प्रोपोर्शन में मैं उसको, सो टॉप फ्लोर विल बी सब्जेक्टेड टू मैक्सिमम lateral force and it will get reduced linearly till at base. तो ये एक अलग हुआ। ओके, अब थोड़ा थोड़ा आगे जाने के बाद आपको ध्यान में आएगा कि वो लीनियर भी नहीं है, एक्चुअली इट इज नॉट लीनियर, it is something parabolic और curvilinear. सो लीनियर लॉ भी आप अप्लाई नहीं कर सकते, तो दूसरा आदमी कहेगा सर इसको पैराबोलिक समझो और पैराबोलिक हिसाब से उसको डिस्ट्रीब्यूट करो, राइट?
Yes, sir.
Now our code has accepted this as parabolic, so raised to 2. Okay, parabolic means anything raised to 2. Quadratic, parabolic or quadratic, you can say quadratic. So the quadratic behavior, so using this law, this entire base shear is distributed at every floor, and let's see how. Clear what?
Yes, sir.
Okay, this is in y direction. Now again 0.32, but even in 0.32, if you see this, you will see that up to 0.5, you are having same. So you are getting same same thing in y direction also, right? So AH is coming out to be same in x and y direction. But if you go for some another example, it may be differ. Here it is coming out same, right? Now this is the law. What is the vertical distribution of base shear to different floor levels? So actually now you have calculated the total base shear. This. Now that you are providing with this law, and you can see that Wi is the seismic weight at ith floor, Hi is the height of ith floor, the height is squared and divided by sum of everything. So I will say W1 H1 square plus W2 H2 square plus W3 H3 square, like that. So that is your quadratic distribution. अगर आप बोलेंगे नहीं सर ये क्यूबिक डिस्ट्रीब्यूशन होना चाहिए क्योंकि वो शेप जो ऐसा लग रहा है it is greater than quadratic, so it is cubic, then you can say 3. Yes.
Yes, sir.
Someone will say that sir actually it is not linear, it is not parabolic, it is in between linear and parabolic. In that case he may say 1.7. So here it will be 1.7, right? So there are n number of distribution laws that people have general code has accepted this parabolic or quadratic distribution. That's why Hi raised to 2 and Aj raised to 2 and summation. Clear? Yes.
Yes, sir.
अभी ये कॉम्प्लिकेटेड लग रहा है?
No, sir.
Because now you have understood the meaning of this. So कुछ नहीं, the seismic weight at ith floor multiplied by height of ith floor raised to 2 divided by sum of all seismic weight with respect to their height square and the summation multiplied by VB. So that will be the total QI, where QI is the lateral force that is coming in picture or design lateral force at I. So I may be 1 to n. If you are having 15 story, then you will have Q1, Q2, Q3 up to Q15. Clear? Yes.
Yes, sir.
अब कुछ नहीं, अब यही सिस्टमैटिक वे से करना है, तो that has been provided over here. So lateral load distribution with height by static method. So here what I am putting story level. So 1, 2, 3, 4. Why only 4? Because in our case we have considered 4 different floors, and then seismic weight of every floor. So story number 1 or floor number 1 for 4,200, 4,200, 4,000, and this is a terrace or roof which is 3,000. Clear?
Yes, sir.
Then height of the floor. First floor is at 4.2.
4.2.
Second floor is 4.2 plus 3.2, that is 7.4 plus 3.2, 10.6 plus 3.2, 13.8. Clear?
Yes, sir.
Now I will square this, multiply this, and put it over here. See, WI HI square multiplied by 1000, that means actually it is 571.3 multiplied by 1000. और फिगर ज्यादा बड़ा ना हो इसीलिए वो 1000 कॉमन निकाल के ऊपर लिया है. क्लियर? So 4.2 square multiplied by 4,200 divided by 1000 will be 74.1, because 1000 is over here, right? So 7.4 square multiplied by 4,200 divided by 1000, whatever is the value, 230. 471.9, 571.3, which is same as 13.8 raised to 2 multiplied by 3000 divided by 1000, 571.3. You can check it, right? Yes.
सही है सर, चेक किया मैंने एक.
Now you can find out the summation. 571, 471, 230, 74. Put it over here, because here we are saying that sum of this. Okay. Clear? Hello.
Yes, sir.
Now the WI HI square divided by WI HI square summation. So summation is this 13.47.3. So I will write 74.1 divided by this, and I will put it over here, 0.055. Okay. Then 230 divided by this will be put it, you can put it over here, 0.171. Then 271.9 divided by 1347.3, you can put it over here. 571.3 divided by 1347.3, whatever is the answer, you will put it over here. And if you make the sum, you will find it. This is not 1000, it is actually 1.000. Okay. Clear?
Yes, sir.
Now you know QI. What is your QI? QI is nothing but equal to VB multiplied by WI HI square divided by summation WJ HJ square, and J from 1 to N, or in our case 1 to 4. So that is exactly this. So WI HI square divided by WI HI square, I equal to 1 to N. So this is, so if I multiply VB by this factor, I will get base shear or lateral load at first floor. Clear?
Yes,
So
sir.
VB, so this is the VB that I am putting in this. So VB multiplied by this, I can put it over here. So VB multiplied by this, you can put it over here, and VB multiplied by this, you can put it over here. And again, you can find the summation equal to 1440. Clear?
Yes, sir.
आसान है? Similarly,
Yes, sir. Now it is. Yeah.
Similarly for Y. Now I will say that finally I got the lateral loads due to earthquake activity for my structure as like this. So these are, I can say Q1, Q2,
Q3,
Q3,
Q4.
Q4. So now you can do it for any building, for any floor.
Yes, sir.
The only thing is that you have to find out VB, you have to find out AH, you have to find out WI, you have to find out T, and you have to find out SA by Z. And based on that, you can use these formulas and you can find out this. Now, once you get these quantities, then you can analyze the structure for these lateral loads as if you have analyzed the structure for your gravity loads. Right?
Right, sir.
सिस्टम वही है जो ग्रेविटी के लिए एनालिसिस के लिए आपने क्या किया, ग्रेविटी फोर्सेस अप्लाई किए. नाउ आपने इक्विवेलेंट स्टैटिक लोड मेथड यूज करके लैटरल फोर्सेस दैट माइट बी जनरेटेड एंड द फ्लोर माइट बी required to resist, and these are maximum. So you are not worried any force less than this, because if the terrace floor is capable to resist Q4, it will be definitely will resist a force less than Q4. Yes.
Yes, sir.
So that is the process, and now I will just show you that. And this is, so this is for earthquake in X direction. This is for earthquake in Y direction. You can apply all these forces at every floor, and you can go for your analysis, and analysis will give you the results based on whatever forces that you have applied. Then once you get the forces, maybe bending moment, shear force, torsion force, axial force, you will design the building. Clear?
Clear, sir.
Any doubt into this? I think मैंने एक की जगह दो सेशन लिए. नॉर्मली मैं इंटायर सेशन एक सेशन में लेता हूँ, बट as you people are a little bit sincere than other batches, I have given a additional session for you. So I have divided in two sessions, and with that, now I expect, or I really expect from you to analyze any other building. You can do that. Calculation of seismic weight, calculation of AH, calculation of time period, and calculation of SA by Z. Then everything you get in 1893, what is Z, what is I, what is R. बाकी तो सारी IS को 1893 ने आपके लिए दिया ही है ना. So
Yes, sir.
earthquake analysis. Now I will say that at least you can analyze any building for lateral load resisting system with the help of equivalent static method. Now there are some, I will say there are some shortcomings of this, but we'll talk that in next session, because in that session we'll see that we'll first find out what are the limitations of this method, and then how we can overcome the limitations, and what additional analysis that we should carry out, and that is dynamic analysis with the help of response spectrum or modal superposition. And then we'll compare the outcome that is generated by dynamic analysis with this static analysis, and will further try to understand the concept, why equivalent static load method should be applied, why dynamic analysis should be carried out, and when they are showing you different different response, how you can take the advantage of both so that your building will be safer. Okay, but that we'll discuss in next session. Till that, if you have any queries, you can ask me, and I hope you people understood it
Sir.
correct. Yeah.
सर शुरू में डेड लोड कंसीडर किए हैं 12 किलोमीटर पर मीटर, वो सर कहाँ से कंसीडर किए हैं?
ओके सी एक्चुअली मैं आपको बताता हूँ, एक्चुअली आपको क्या करना पड़ेगा when you are going for calculation of seismic weight. See, this is your floor. Okay, let's say, and you are having columns over here. Now you are finding out a weight of this floor. You can say that this is your weight of the floor, which will include DL plus SIDL or
Okay, sir.
STL, right?
Yes, sir.
Let's say you are getting dead load as 3.5 and you are getting STL as 1.5. So how much it is? 3 plus 1 and 1.
5 हो जाएगा।
So 5. So actually dead load that you are getting kilonewton per square meter. Okay. And if you consider live load, that live load may be something around 3 or 2.
Yes, sir, 3.
So together it will be 8. Right. Now what is left? There may be, see, this is your, this, let's say this is your 50%. So this is your wall. Yes.
Yes, sir.
So accordingly, you have to consider all walls with and half of the height of the wall plus all columns. That is because here you might consider weight of slab and weight of beam that you can consider, but weight of column is missing. Right.
Right, sir.
So then you can find out the, as you know, the sizing of columns and height of the mid height of the column. So you can find out the weight of columns and weight of walls. Clear?
Clear, sir.
So that is additional dead load. But अगर हम लोग ये सब लेते थे इसी में, तो lateral load analysis का concept छोड़ के इस पर ही ज्यादा काम करना पड़ता था. So what we have done? So this 5 plus effectively say 7. So it was 12.
Well,
Okay. And this was 4. So you can say that was 4. Okay.
yes, sir.
Now at terrace, what is happening? At terrace, you are getting only periphery walls and that to 1 meter height. Right? 1 meter height. And that's why that is considered as 10. So that calculation of weight of beam, weight of column, then weight of 50% BB masonry below, 50% above was here. It was approximated as 12 and 4 and 10 and something. I think it was 3, whatever live load. So 10 for roof and 12 for floors.
Floor.
That was considered over here. But in actual case, you will have to find out this properly, because that will depend, that will differ from building to building, right?
Right, sir.
But for understanding, see here we are not focusing on calculation of weight. We are focusing on calculation of lateral loads with the help of equivalent static load method. That's why we have approximated it as 12 and 10. Clear?
Yes, sir.
But that was nice question. I think you were working on that, and that's why you got that difficulty. ऐसे क्वेश्चन पूछना पड़ेगा यार, तब जाके हम आगे जाके ज्यादा बोलेंगे.
Okay,
Clear?
sir. Clear, sir.
But now you can calculate weight of wall, 50% wall below, 50% above, then weight of beam and weight of column, 50% below and 50% above, and then that will be added on the floor.
Okay, sir.
Yeah. Anybody else having any other query? अरे जितना ज्यादा क्वेरीज पूछोगे उतना अच्छा रहेगा आपके लिए. एक्चुअली मेरे लिए वो प्रॉब्लमेटिक है, बट आई लाइक दैट, क्योंकि अगर
नेक्स्ट क्लास में पूछूंगा. अभी कुछ डाउट है, लेकिन मैं पढ़ लूं
अगर
फिर
सर
बाद में पूछूंगा.
सर अगर
या
इरेगुलर स्ट्रक्चर हुआ तो सर उस केस में फिर ये लैटरल लोड वाला कॉन्सेप्ट काम करेगा या फिर
वो यही तो मैंने बताया, देयर आर सम लिमिटेशंस, वही तो हम अगले सेशन में देखेंगे.
ओके.
या येस, एनीबॉडी? शहाजी पाटील, अहो मराठी माणूस मागं राहून कसं चालेल? यस, कुछ नहीं, मैं उसको पूछ रहा हूँ. मराठी आदमी पीछे नहीं रहना चाहिए. यस, एनीबॉडी एल्स? नो, ऐसा कुछ नहीं है. सारे मेरे स्टूडेंट है, वेदर यू आर फ्रॉम महाराष्ट्र और एनी अदर स्टेट और इवन फ्रॉम एनी अदर कंट्री. थोड़ा मजा भी चाहिए ना.
यस सर.
Yes, anybody else? Or shall I conclude today's session?
यस सर.
Okay. Then thank you. And come with questions. मैं बार बार कह रहा हूँ.
Thank you, sir.
Thank you.
एक्सक्यूज मी सर.
Yeah.
सर जो आपने रिस्पांस रिडक्शन फैक्टर बताया था सर, उस केस में सर अगर डक्टाइल डिटेलिंग वाले में फिर एक टेबल दी हुई थी, उसका यूज करेंगे क्या सर?
Which one?
सर रिस्पांस रिडक्शन फैक्टर आर.
You're talking about this.
Yes sir, this one.
See, this is again, the buildings are having various. Some buildings are ordinary RC moment resisting frame, where ductile detailing is partly covered and partly neglected. In that case, you cannot go for R equal to 5. You have to go for R equal to 3. If you are having your moment resisting frame, special RC moment resisting frame, that means if that frame is detailed as rigid connection and detailed as ductile detailing, that is whatever that ductile detailing requirements are given in 13920. If you are having the frame detail like that, then you can go for R equal to 5. Then in steel frame, this concentric braces and eccentric braces, you can go for this. But this was again, I will say this page 23. They are showing a lot of details, or they may be asking for you to go to SP16. But now this ordinary moment resisting frame is disallowed by the lateral load resisting or 1893 codal provision. They say now that concession is not applied. Now that was the old concession. Now that
Okay, okay.
concession is uh, waived off. So whether you are going for ordinary moment resisting frame or SMRF, that is special moment resisting frame, you have to go for ductile detailing. See, earlier what the code used to say that if you are designing it as a ordinary moment resisting frame, then whether ductile detailing is to be provided or you can exempt from that, that was your choice. The code has given you the choice. Now that choice is waived off. Now the code says it is your choice whether you are going for R equal to 3 or whether you are going for R equal to 5. That is your choice. But under any circumstances, you must go for ductile detailing. आपको उसमें उसमें कोई एग्जाम्पशन नहीं मिलेगा, उसमें कोई डिस्काउंट नहीं मिलेगा.
Yes, sir.
And that is exactly, this is the point where, see, अपने इंडिया में लोग बहुत होशियार रहते हैं. वो क्या बोलते हैं? आई एम यूजिंग R equal to 4 so that my VB is more. VB will be more, no? Than when
Yes,
someone else is using R equal to 5, then he will have VB less. But R equal to 4,
yes,
he will have VB more. So because of I am designing my building for higher VB, that ductile detailing I can waive out. But now strictly code says we are not interested. What are that you should account is your choice. You may go for R equal to 3 or you may go for R equal to 2. That is your choice. Maximum you can go for R equal to 5. Anything less
yes,
than this is your choice. But that doesn't mean that you are free to go for non-ductile detailing. That is not accepted. Previously, it was accepted. Code used to say that, okay, if you are having ordinary moment resisting frame, you can go for R equal to 3 and you can waive out that ductile detailing. But now code says nothing doing. अगर आपको lateral load resisting frame use करना है for resisting the lateral loads, you must go for ductile detailing. Otherwise, it will not be accepted.
यस सर. यही डाउट था सर मेरा कि वो यूज लेंगे या फिर इसमें चॉइस है, कैसे है. आज
ये
क्लियर हो
पहले
गया
था.
सर.
You're right. पहले था. Something before 2016. In that 2016 revision, see, whatever we are showing you over here is with the help of 2002. That's why the choice is there. But now in 2016, code is saying that it is up to you whether you can use R equal to 3, R equal to 5, or you may use R equal to 1. That is your choice.
यस.
But you have to go for ductile detailing. And when I am going to cover the ductile detailing, I will give you the additional information why code is so stringent. क्योंकि वो stringent ना होने की वजह से ही भुज या अहमदाबाद में जो कैलामिटी हुई, जो
यस सर.
सफर करने पड़े, वो किए. तो अभी वो वेव अप किया है. Okay.
यस. थैंक यू सर.
Okay. Any other query? क्वेरी पूछोगे तो ज्यादा आपको मिलेगा, नहीं पूछेंगे तो जितना बेयर मिनिमम मैंने दिया है उस पर आपको संतोष करना पड़ेगा. सो इट इज अगेन अप टू यू. अब देखो, ये अगर क्वेरी नहीं पूछता था तो ये मैं नहीं बताता था ना. यस. Okay, then I think now, but even if you are having queries later on also, you can ask me at any time.
Okay.
Okay. So with this, I will conclude today's session and we'll meet day after tomorrow.
Okay, thank you, sir.
Thank you. Thank you.
Good night.
Good night.
Thank you.
Good night, sir.
Yes, thank you everybody.